Bismillahirrahmanirrahim. Welcome to class of Irrigation Engineering section A and D. At the moment, 27 students are with me. I have already started the recording. So we can take a few minutes to take your question. If you have any question from what we have studied till now, किसी के कोई सवाल हैं, कोई comments हैं, कोई suggestions हैं, you are welcome. Hafizur Rahman. Hafizur Rahman. Can I talk to you, Hafizur Rahman? Inamullah.
Yes, sir.
Are you getting my voice properly?
Yes, sir.
Okay. Can you tell me what did we study last time? Just in a few words or few comments, few lines. What were the topic which we studied last time?
Sir, वो lecture revise नहीं किया था.
No need to revise. If you listen it, just whatever you remember it. Did you attend the lecture last time?
Yes, sir. I attended, but I didn't revise the lecture.
It was about what topic? It was about इनाम. किस टॉपिक के मुतालिक हम पढ़ रहे हैं? जी इनाम.
Yes.
आजकल हम किस टॉपिक पे हैं? $174 इनाम. Okay, Inam, I am marking some marks for you in negative side, and I am recording it then. Just attending the class is not sufficient. Okay, who will tell me? Ghulam Mujtaba. Ghulam Mujtaba, please switch on your mic. $174 is one Inam. And who was not answering me? इनाम के साथ कौन था? हफीजुर रहमान. I did not get answer from you. गुलाम मुज्तबा. Ali Usama. Ali Usama. Lusam, I am not getting your reply, so I am removing you from the class. Ghulam Mushtaba, I am not getting response. I am removing you from the class. Irtaza Naveed.
Yes, sir.
Irtaza, are you getting my voice?
Yes, sir.
So can you tell us what topic we are studying nowadays?
सर क्रॉप वाटर रिक्वायरमेंट पढ़ रहे थे और लॉसेस जो क्रॉप्स में होते हैं.
थैंक यू वेरी मच. ये इनाम इतनी सी बात थी बेटे.
Yes, sir.
इतनी सी बात थी कि मैंने सिर्फ टॉपिक पूछा था. मैंने ना कोई याद करने वाली चीज पूछा था ना कुछ. क्या पढ़ रहे हैं सिर्फ ये पूछा था. थैंक यू इर्तजा. रोल नंबर 20. Irtiza, roll number 20. +5 for Irtiza. Whenever I have chance, I will put these marks. Okay, now it is a general question from anybody. You can raise your hand. Tell me, one thing is evapotranspiration and one thing is metabolic use of water, the biological use of water by the plants. When we combine these two things together, what do we call it? Evapotranspiration plus metabolic use is called as, just raise your hand. Thank you, Farooq Hassan ji.
Sir, it's called consumptive use.
So we call this thing ET, evapotranspiration plus metabolic use, as consumptive use. That's true. So thank you, Farooq. Where is this Farooq?
Yes,
Who will
sir.
tell me if I add in consumptive use the losses and any special uses, if I add, what do we call that thing? Hand raise. Roll number 3. J.
So it is called as crop water requirement.
So we call it as a crop water requirement. So crop water requirement is combination of 4 things. So that is true. And anybody will tell me in Lacey equation for estimation of losses, there was an equation of Lacey for estimation of losses. What were the units of length?
1000 feet.
1000 feet. तो ये वाली equation की मैं बात कर रहा था. So okay, we reached up to that point, up to the losses, I think. Let us go ahead. We have to go through some further definitions. Consumptive use हमने देख लिया. Evaporation, transpiration, I think we have done it. And so combined together, we call these two things as evapotranspiration. Out of this, evaporation occurs from the soil and transpiration occurs through the leaves, through the stem, through the flowers, mainly from the leaves. These evapotranspiration can be calculated or can be measured at different time scale. We can measure it on hourly basis, we can measure it on daily basis, we can measure it on monthly, weekly, seasonal basis. So at various time scale we can measure. So depending upon this time scale, you can see in the literature, either it will be daily consumptive use or it will be a peak consumptive use for a period. Peak consumptive use for a period or peak period consumptive use, or it can be a seasonal consumptive use. So all of them are utilized for different purposes. A daily consumptive use is similar to what we have shown to you in the graph. I think this graph was showing the daily crop water requirement are part of that. The consumptive use was being shown over here. But if we see this daily consumptive use, it fluctuates quite high. So sometimes we sum up together the daily consumptive use of a few days. Usually 6 to 10 days are added together, and that we call as the period consumptive use. When we add 5 to 10 days or 6 to 10 days consumptive use, we call it as a period consumptive use. So if during the whole crop period, during the whole crop age or crop duration, we can have a number of period consumptive use of 5 days, of 5 days, of 5 days, or 10 days, 10 days, 10 days. We have a number of those period consumptive use. So one of them will be the maximum one. So that we call as the peak period consumptive use. It is the average daily consumptive use during a few days of highest consumptive use in a season. In the whole season of the crop, the highest consumptive use of a few days is called as a peak period consumptive use. This one we utilize while we are deciding the discharge capacity of a canal. We are not deciding the capacity of the canal or the requirement for a canal or requirement of a certain area based upon daily use. These are quite high. Daily consumptive use is quite high. It varies from low to high, so the highest value will be quite high. So we take a few days together, and then that becomes a kind of average one. So that we use as a peak consumptive use, peak period consumptive use for planning or designing of a new irrigation system. So that one you will be using in the lab part also, not the daily consumptive use, not the seasonal consumptive use, rather peak period consumption. Usually in Pakistan, we practice the planning on 10 daily basis. We report the discharges, we report the flows, we report the demands on 10 daily basis. So irrigation canals should also be planned on 10 daily basis. That is how we do it. It is a seasonal consumptive use is the amount of water which is used by the crop during entire crop period. So crop period is from sowing of the crop till the harvesting of the crop. So that is the time period during which whatever is the consumptive use by the crop, so that will be the seasonal consumptive use. This we use for carrying out the seasonal planning, or when we carry out the overall budgeting of a country or for region. So then we use this seasonal consumptive use. This daily consumptive use can be utilized for research purpose, or it can be utilized to see what is the maximum consumptive use. And if we have to decide the water supply from source during different period of the crop, so if we are supplying on daily basis, but we are not supplying on daily basis, then this would have been used. So this is more like for a research purpose. So we utilize for planning purpose this peak period consumptive use. Just to give you an idea how much can be this consumptive use over the whole season, not for a daily or not for a period consumptive use, for different crops which are which are cultivated in Pakistan. We have given this figure that, for example, wheat needs about 37 centimeter of water. If you see in inches or in feet, so it will be a little more than a feet. 30 centimeter becomes 1 feet. So it would be about, I think, 15 inches of water is required uh, by wheat to grow fully in Pakistan. Uh, you can see some literature which are mentioning just 30 centimeter as a wheat consumptive use, some mentioning 35 centimeter. So something close to 35, 37, 30 centimeter is the consumptive use for wheat. Similarly, you can see that these are requiring the similar amount of water. In Kharif season, you are familiar with Rabi and Kharif season. Rabi season have just finished in Pakistan, end of March it finished, and now we have entered into Kharif. So we call this season as the early Kharif season. So during this season, in some part of Pakistan, people are growing the Kharif season. They have already in Sindh area, in the province of Sindh. Hopefully, the wheat has been harvested, and it is being harvested, and uh, they are planning for the next crop of the season, next crop of the Kharif season. They are maybe sowing this at this time, cotton and other maize and rice. So during this early Kharif season, you see it is very dry season. We don't get much rainfall. So we utilize the water stored in the reservoir during this season, and we release water. So cotton, which has a nearly similar crop period, the duration of the crop is nearly similar to wheat, and this uh, it needs up to 40 centimeter of the water. So that is close to the wheat. Rice needs huge quantity of water. If you see, quite distinguished from the other crops. Rice has similar length of the crop. Crop period is similar to other. It is also about 5 to 6 month crop. This is 4 to 5 month crop, wheat and cotton. So rice needs huge quantity of water. In centimeter term, you see up to 150 centimeter, 1.5 meter of the water is required by rice. And the similar amount is required by sugarcane, 1 meter, close to a meter, 90 centimeter or 100 centimeter is required by sugarcane. So sugarcane is an annual crop. It remains in the field for 9, 10 months. So we call this crop as an annual crop. Rice is a seasonal crop. It is a kharif crop. So these are the kharif and rabi crop. I don't expect you remember all of them, but for major crops, you should know the water requirement or consumptive use by these crops. For example, you should be knowing how much water is approximately required by wheat, how much is, it will vary from one place to other place by few centimeters. So, but you should have an idea of the range of the water requirement by wheat, rice, cotton, and sugarcane. These few definitions which will be required for estimation of the crop water requirement. So in crop water requirement, one of the important part is evapotranspiration requirement. Conveyance losses we estimate through the equations. So that is a separate story, so separate part. The consumptive use having metabolic requirement and having the evapotranspiration requirement, 99% up to 99%, from 97 to 99% water required in consumptive use is evapotranspiration requirement. Metabolic requirements are very minute, very less. So that's why we are people are focusing more on estimation of the evapotranspiration requirement. So evapotranspiration requirement, one way of estimation of the evapotranspiration requirement is for a certain crop, for example, for wheat, if we want to estimate is, one way is to have evapotranspiration requirement for a standard crop. People are carrying out research on this topic, water requirement by crops. So while they were carrying out the researches, they found that it is difficult to compare research at one place with the research at other place, because one person was carrying out the water requirement for one type of the crop, other person was carrying out the water requirement for other type of the crop. So it was difficult to compare with each other. So then they propose that let us carry out the research in different area on the similar crop, and they define that crop and they name that crop as a reference crop. They say this will be considered as a reference crop. So when one person is mentioning or measuring the water requirement for same crop in Lahore, same crop in India, same crop in Australia and USA, so then and they are using different methods, so then they can compare the methods suitability with each other. Then they can compare the climatic differences from one place to other. If same crop I am growing at Lahore, same I am growing Faisalabad, and I am calculating their consumptive use or evapotranspiration requirement. So if there are differences, crop is same, so difference will be then because of the climate, difference will be then because of my irrigation methods, different will be because of the soil condition. Crop will not be the reason for the difference. So to compare the results with each other, to have the better idea about researches at different places, people have coined, people have proposed, especially there was a researcher named Allen. In 98, he proposed the name of this, he proposed a standard crop. He defined standard crop, and he said that this standard crop is more or less similar to a well-grown grass crop which is covering the whole land, which is covering the whole field, and it has lush green grass without any shortage of water. So without any disease, without any shortage of water, if grass is covering a certain area with a height of 5 inches or 12 centimeter, then he say it resembles to the reference crop, or we can say this is as a reference or standard crop. Scientifically, to define it, so a well-grown grass of height 12 centimeter is reference crop, but to measure it more precisely, it is defined that reference crop is a grass crop, hypothetical mean assumed grass crop, which has a height of 12 centimeter and which have a surface resistance of 70 seconds per meter, and which has albedo of 0.23 or 23%, which has albedo of 0.23, which has surface resistance of 70 seconds per meter, and which has a height of 12 centimeter or 0.12 meter, and it is a grass crop with these characteristics. If a grass crop is there with these characteristics, we will be saying that this is a standard crop. And the evapotranspiration requirement for this standard crop or reference crop will be called as reference crop evapotranspiration. And we will be showing it with the subscript 0. We read it as ET naught, ET subscript 0, so we read it ET naught. So ET naught refers to evapotranspiration requirement for reference crop. Reference crop evapotranspiration, if we know, so it means the effect of crop is gone. So it will be showing us the climatic effect of that area, and it will be showing us the local practices over there. But even local practices are covered in cropping factor, crop coefficient. So it will be mainly showing us the climatic effect of that area. How much is temperature, how much is the humidity, that will control the ET naught in that area. So this is required, or this we use to calculate evapotranspiration requirement for a crop of our interest. We are not particularly, we are not interested in reference crop, we are not growing that everywhere. So we are actually interested in crop of our requirement, like wheat, rice, cotton, sugar cane, grams, maize, barley, these things we are interested in. So this ET naught is multiplied with a crop coefficient for a certain crop, and we get the evapotranspiration requirement for that particular crop. So that is how ET naught is utilized. ET naught is said to be dependent upon the climatic factor, because the crop factor has been made constant, crop have been defined well. So let me tell you what do we mean by surface resistance and what do we mean by albedo. So albedo is a reflection coefficient, coefficient of reflection of a certain surface. Each surface reflects the energy. We are getting energy from sun. Some of this energy is absorbed by that surface, and some of that energy is reflected back. So depending upon the wavelength it reflects back, the color of that thing is decided. If the reflected energy is of the wavelength 0.6 nanometer or close to that thing will look to be greenish to us. If it is about 0.7 nanometer wavelength, uh, I think 0.7 nanometer wavelength, then it will look to be red. If it is zero point 0.4, 0.5 nanometer wavelength, it will look to be blue to us. So depending upon which wavelength is reflected, so we see the color. So that is a separate thing. But how much energy is reflected by the surface and how much energy is incident on that surface. If we take the ratio of these two, that ratio is called as albedo or reflection coefficient. It is a ratio of the energy or the light reflected by the surface divided by the light incident on the surface. So it shows us how good reflective a surface is. So those things which reflect all the energy back to the atmosphere, we are getting energy from the atmosphere. It is incident on a surface and then it goes back into the atmosphere. If it reflect all the energy back, that will its albedo coefficient will be 1. It is not absorbing much energy, so it will not have energy for its evapotranspiration requirement. So those things which seems to be white to us, they are reflecting back all the light energy back to the atmosphere. They will not get up heated very soon. They will not get much energy for evapotranspiration. And those which are of dark color, so those will be absorbing maximum energy. We are not getting the reflection much. So greenish things have albedo coefficient close to this 23% or 0.23. Out of the 100 units of the energy incident on the surface, 23 units are reflected back. They are not using it. Remaining 77 units are being absorbed by that surface, and that will be utilized for evapotranspiration or consumptive use of that surface. Surface resistance is the resistance offered to the vapors when vapor try to escape the plant stomata. When the water tries to escape the plant through the leaves or through the opening of the leaves, we call them stomata. So when it tries to leave that, so plant offers some resistance to that evaporating or transpiring water. So when water enters into the roots, goes to the stem, goes to the leaves, ultimately it leaves, it escapes from the plant through the stomata. So the resistance offered by the plant is that surface resistance of the plant. It is different from one plant to the other plant. And the height, you can easily understand, height controls evapotranspiration requirement. So that's why the grass height is fixed for reference crop. So reference crop will be having a height of about 12 centimeter, surface resistance this much, because it controls evapotranspiration, and it will have this much surface condition, how much energy is being reflected. So albedo will be 23%. So this ET naught has utilization for estimation of the actual crop evapotranspiration, which we call as ET subscript C. For example, actual crop evapotranspiration for wheat will be ETC for wheat. So that we can calculate if we have crop factor for the wheat KC and we have the reference crop evapotranspiration ET naught. So this ET naught can be calculated from different formulas based upon temperature, based upon evaporation, based upon other factors. ET naught is first calculated, and then from other kind of researches we can have crop factor. and we can multiply these two things together and we get the ETC. So that is how people are working in estimation of the crop water requirement. So these consumptive use or evapotranspiration requirement are dependent upon climatic factors because it is evaporation and transpiration. So climate plays important role because climate provides us the energy for its for vaporizing water, for conversion of the liquid water into the gaseous water, that is the evaporation process, we need energy. So energy is coming from the climatic factors. So this solar radiation, this temperature, these are the controlling the energy. Other climatic factors which affect the evapotranspiration requirements are precipitation, wind speed, relative humidity, and you can well understand because you know how wind speed affect the evaporation. More the wind speed, more will be the mixing in the atmosphere. So more is the possibility of evaporation from the surface of the plants or soil. Relative humidity is inversely proportional. More the humidity in the atmosphere, uh, more resistance will be offered for evaporation. So less will be the evapotranspiration. So relative humidity is inverse. Wind speed is directly proportional. Temperature and solar radiation gives the energy. So they are directly proportional. Higher the solar radiation, more energy is coming, more will be evaporation. More is the temperature of soil or plant, more will be evaporation. So when there is precipitation with greater frequency and amount of the rainfall, it becomes higher. Reason for that is if there is more precipitation, if more frequent precipitation occurs, water remains always available for evaporation. If there is a persistent long dry period, neither water is available for evaporation and neither water evaporates. So when it is not available, how can it evaporate? So if there is a sufficient quantity of precipitation occurring, evapotranspiration measurement in that area will be higher as compared to a dry area. Other factors which affect the evapotranspiration are related to the crop and the soil and the practices being followed in that area. Practices related to irrigation methods, practices related to the agriculture, cultivation or sowing practices. So growing season do affect the crop water requirement or evapotranspiration requirement or consumptive use because it affect the evapotranspiration, so it affect consumptive use, so affect the crop water requirement. So growing season affected. Why it affect? Because initially crops are very small, then they'll increase in their mass, they increase in their size, their leaf area index increases, their number of leaf increases, so their transpiration enhances. And the other thing, evaporation, initially when crop is small, most of the soil is bare, most of the soil is open to atmosphere, no shade is there on the soil. When crop is very small, most of the soil is open to the atmosphere, so evaporation will be high in the initial phase of cultivation of the soil of the crop. And as the crop grow, evaporation will reduce because the open surface to the atmosphere will be less. Most of the surface will be covered with the crops, so transpiration will enhance. So overall, with the growing of the crop, it has been seen that it increases the evapotranspiration till the maturity of the crop, and then it reduces at the time of harvesting. Usually what we see, the increase of the crop water requirement take the shape of this line. Initially less crop water requirement or evapotranspiration requirement, then during the, so here you are seeing the crops itself. So with the development of the crop, with the enhancement of the size of the crop, the crop water requirement enhances. Here we are showing you the cropping coefficient, but same is the trend of the evapotranspiration requirement. So evapotranspiration requirement enhances, then a maximum quantity is reached, and then at the time of harvesting it goes back to the lower values, so it reduces over here. So based upon these requirements, crops total time period is divided into 4 phases: initial phase, development phase, middle phase, and late season. So that is how we can see that the crop growing season do affect the evapotranspiration requirement. Reason is how much soil is open to the atmosphere, and the second reason is how big is the crop, how much is the leaf, number of the leaves or the leaf area index of the crop. Second thing, crop characteristics. Two crops do not match with each other with respect to their biological characteristics, with respect to their leaf area, with respect to their stomata opening, with respect to their surface resistance and albedo. So when they are not same biologically, when they are not same with respect to their size and mass, how can we expect that their evapotranspiration requirement will be same? So depending upon their growth habit, some grow very quickly, some grow very slowly. Their canopy development. Canopy is the top surface of the plant. So if you see some plant or some forest area from the top, you are seeing the canopy of the vegetation. So its canopy development, more the leaves, more will be the well developed will the canopy. So leaf area index is the a scientific term. We call it as the area of the leaves divided by the shade of that plant. So if we see a plant from the top surface, it has a certain area. If we measure that one, and also we measure, we take out the leaves of the plant and we spread them on the land, and then we measure that area also. So the ratio of the area of the leaves to the area of the canopy of that plant, so that we call as a leaf area index. So those plants which have broader leaves, those plants which have more leaves, so they will have higher leaf area index. When a plant has higher leaf area index, its evapotranspiration is expected to be more, because more area is there for transpiration. Plant density means how closely the plants are cultivated. So these are some of the characteristics which affect the evapotranspiration requirement, and we combine them together in the crop characteristics. Soil do control to some extent the evapotranspiration requirement, because some soil have more affinity to the water, more cohesion with the water or adhesion with the water, and some have less. Some have more pores to have the water, some have less pores to hold the water. So depending upon different characteristics, different soil, some let the water escape easily, evaporate easily. Some keep them tight with them. So that's how the soil characteristics affect the evaporation. So those soils which have more affinity with the water, more strong bond with the water, so they will not let evaporation to occur easily. Their ET will be less. Those which let the water go out easily, their ET will be high. Evapotranspiration requirement will be high. Some local practices do control practices of irrigation. We can apply water to a plant, to a area in different ways. We can flood the area, we can make the furrows and channels, and we can provide the water, we can sprinkle the water, we can provide the water through drip irrigation, and there are other methods, border method, strip method, check method. So there are different methods of irrigation. So depending upon how much area is soaked, how much is the standing water for how much duration, evapotranspiration changes. So irrigation practices and the frequency of irrigation both. If we carry out irrigation in small quantity, more frequently, every day if I irrigate, more evapotranspiration will be there. As compared to that, if I keep irrigation today and then after 10 days or 15 days, then there will be a small period in between, there will be less evaporation. So overall ET requirement will be reduced. So frequency of irrigation, method of irrigation, how much depth of water I have provided, that is the depth of irrigation. Fertilizer also, application of the fertilizer. If we have a field on which I have applied the fertilizer, and if I have a field on which I have not applied the fertilizer, that field which is with the fertilizer, that will grow more in a better way, that will grow more, so its water requirement will enhance, its transpiration requirement will enhance. So it has been seen that the ET also changes with the fertilizer application. Also there is a practice they call mulching. Mulching means covering the land with some artificial or natural surface so that the evapotranspiration requirement should be reduced. So now area are the regions in which water is much stressed. People are practicing a kind of cultivation, they call it thin film plantation. They cover the area with the polythene sheet. They puncture it at the place where they want to cultivate a plant or a seed. So they puncture it at that place, make a hole, and they plant that seed over there. And the remaining whole surface is covered with the polythene sheet. Similar method can be done by covering the area with the dry leaves of the previous year or previous season crop. If we have the extra leaves of the previous crop, we can leave them on the field, and that can cover the field also. So that gives some protection to the soil. Evaporation reduces. Either film polythene sheet can be used to reduce the. So these practices of covering the soil with some artificial thing or with the leaves, so that is called as mulching. Mulching is covering of the soil by a rotten vegetable or with the film or with the polythene sheet. So such practices, if are carried out in one field and such practices are carried out in another field, so it will change the evapotranspiration requirement. So these are some of the factors which you should keep in mind, that evapotranspiration requirement do change. Mainly it is the climatic factor, mainly it is the crop, mainly it is the these and the growing season. These are the main factors. These are the small factors which affect. So any questions up till now? As we have said to you that for calculation of ETC, evapotranspiration requirement of the crop, we need to multiply a crop coefficient with the reference crop evapotranspiration. So we should also define what is Kc, what is crop coefficient. If we rewrite the previous equation which we have seen over here, if we rewrite in another way, we can find its definition of Kc, that Kc is the ratio of the evapotranspiration requirement of a crop to the evapotranspiration requirement of the reference crop. So ratio of the evapotranspiration of a certain crop to the reference crop evapotranspiration is called as Kc. So from where we will be getting this Kc? Kc we get from the a study which we call as evapotranspiration requirement, a measurement using lysimeter. Lysimeter is an instrument. Let me show it to you first. So lysimeter looks like this. We grow a crop in it, and then we measure the water which we give to that area, and measure the water which leave that area, and we can estimate how much is the evapotranspiration. So this lysimeter will give us the ETC, actual crop evapotranspiration for the crop which we have grown in the lysimeter. Similarly, from the lysimeter, we can study the reference crop evapotranspiration. If I grow a standard crop in the lysimeter, the grass is grown of 12 centimeter height, so then that will be ET naught. So ratio of these two is carried out, and we can find the Kc from such research study. We don't carry out on ourselves on daily basis. So those people who are related to agriculture or agronomy, they carry out such studies, and then they report Kc value. We as a planner of irrigation scheme, we will be using this Kc value developed or found by different researchers in the area for which we are developing the irrigation scheme. So these Kc value you can find from the literature, you can find from the studies which have measured the actual crop evapotranspiration, and then they have calculated the Kc value from actual crop evapotranspiration and standard crop evapotranspiration. It mainly affected by the type of the crop. So different crop have different Kc. At different stage of the crop, Kc changes, as we have seen over here. So it is changing with the crop growth period, and it is changing with the crop type and irrigation method. Now this part is the measurement of evapotranspiration. Tens of methods are available, only few are listed over here. We can group all these methods into 3-4 categories based upon the concept they are using to estimate the evapotranspiration requirement. The concept they are using to estimate. Some people have estimated the evapotranspiration requirement by directly working in the field by growing the same crop over there, and they have measured it, and they measure the water applied to that area, water drained from that area, and then the difference they have calculated, and they have estimated the evapotranspiration. So such method in which they measure the mass of water which is given to the area or to the crop, and the mass of water being released from that area or being outflown from that area. So that such method we call as the mass transfer methods. So there are a group of methods which can be grouped under the category of mass transfer method. So this slide is a little bit changed. Previously, empirical method I have written to these things, I think. So from the literature, I have upgraded it. So use this slide. So that will be the better way of representation of these methods. So those methods which measure the water inflow and water outflow and then estimate the evapotranspiration requirement. So we call them as a mass transfer method. Some methods we measure a certain parameter in the field, and then through the empirical through some coefficient we multiply that coefficient with that parameter and estimate the evapotranspiration requirement. For example, we measure evaporation in a pan and then multiply it with a coefficient, and I say that this is the evapotranspiration requirement of the crop, or this is the evapotranspiration requirement of the standard crop. So such methods are called as empirical method. We don't understand the detailed physics behind them. So we have a good relation. We get the answer from that equation or that relationship. So we call them as empirical method. And I think this Blaney-Criddle method and US and the pan evapometer methods, in which we measure the evaporation in a pan and multiply it with the coefficient, we can term them as empirical methods. Some detailed methods have been coined in which we try to relate the evapotranspiration with the physics behind the evaporation and transpiration, with the physics behind it. For example, we can relate the energy with the evaporation, because we know how much is the latent heat of vaporization, the energy required for conversion of a unit quantity of water from liquid state to the vapor state. So I think that is the latent heat of vaporization. We know this value for water. So if we have this latent heat of vaporization information with us, that is a constant value, then if I measure the energy available, so then I can estimate how much will be the evaporation, how much will be the evaporation from that area. So such methods which rely on the physics, so those are more, we call them as a physical based methods. Or if we use the concept of the energy balance, and how much is energy coming, how much is the energy going out, the remaining energy is available for evaporation, convert it into the evaporation, use the formula of latent heat of vaporization and convert it into the vaporization. So such methods are grouped into another class of method. We call them energy balance method, and sometimes we use a part of the method as the empirical and the part we use as the energy balance. So we call them as a combination method. So this Penman method, modified Penman method, radiation method, these can be grouped in this category, energy balance methods. So we intend to tell you frequently use these two methods, pan evaporation method. This is an empirical method and very easy method. And the data required for this is easily available in most of the places around the country. And the second method, which is also empirical method, Blaney-Criddle method, we intend to tell you. and we intend to tell you this lysimeter method. If somebody want to further study these things within these slides, I have kept hidden some of the slides. If you go down, some of the slides are kept hidden. You can go to them like this 50, 51, 52. So you can go through the other methods also, but mainly we are focusing on these three methods: lysimeter method, pan-evapometer method, and the third thing is the Blank-Riddle method. So I take a break over here. So after the break, I will start this explanation of these three methods. So if you have any question till now, you are welcome to ask. What we have studied is what is evapotranspiration, what are the factors affecting it, what else, definition of reference crop or standard crop we have gone through, how we can use the reference crop evapotranspiration to convert it into the crop evapotranspiration using the cropping factor, K factor. And then we have gone through the grouping of the method which are used for evapotranspiration measurement. So that is a summary of what we have covered till now today. So any questions? Any suggestions? Any questions? कहाँ गया वो? How are you, Inam? Not Inam. Yes, Inam. 174.
Yes, sir.
क्या हाल है?
Yes, sir.
आज का
Alhamdulillah.
टॉपिक कैसा है और प्रीवियस टॉपिक कैसा था?
Yeah.
Can you summarize what we have studied today? Urdu, English, anything. Language should not be a barrier.
सर पढ़ना
शर्म करो, तुम्हें कोई कहानी सुनाए तो तुम उसे रिपीट नहीं कर सकते? हैं? This is a skill, this is a trade which we want to develop in all the students, so that if they read something, they should summarize it. If they listen something, they should say it in their own words. Describing something is required in each student, in each expert. आप कुछ सुन के अपने लफ्जों में बयान करना सीखो और शर्माओ नहीं। इनाम, शर्माने का कोई फायदा नहीं। We all are student, including myself. We are learning from you, you are learning from us. तो इसमें कोई मसला नहीं, कोई चीज गलत हो जाएगी तो कोई मसला नहीं। और मैंने कंप्यूटर से निकल के तुम्हें थप्पड़ थोड़ी लगा देना है, इसलिए डरो नहीं। बोलो क्या बोले आज मैंने, किस बारे में बातें की। शो मी योर फेस। मुझे मच्छर काटे जा रहे हैं यहाँ पे। शो मी योर फेस इनाम। If it is possible. कहाँ बैठे हो, किस सिटी में हो?
सर पाकपतन।
और पाकपतन का इतना पाक इलाका है?
यस सर।
आज हमने क्या पढ़ा है? कैन यू डिस्क्राइब इट? एक तो एक मोबाइल से ना पढ़ा करो, हिल रहा है।
सर एक्चुअली मेरे वो लैपटॉप में सर इशू आ रहा था सर, तो इसलिए मोबाइल से यूज करनी पड़ी मुझे।
मोबाइल से नहीं पढ़ा जाता, मुझे आइडिया है
सर, क्योंकि वो कनेक्टिव
अटेंडेंस के लिए ठीक है, अटेंडेंस लग जाएगी, लेकिन मोबाइल से पढ़ाई नहीं होती।
सर हमने ना क्रॉप वाटर रिक्वायरमेंट्स में पढ़ी है, तो इसमें वो हमने वो जो फैक्टर मतलब इफेक्ट करते हैं, हम उसके बारे में स्टडी किया है। तो जैसे कि हमने ग्रोइंग सीजन में जो इफेक्ट करते हैं, तो जो भी फैक्टर्स है वगैरह, तो उनको हम मतलब स्टडी किया है। और इसके अलावा डिफरेंट सॉइल कैरेक्टरिस्टिक्स हमने वो भी स्टडी पढ़ी इसमें।
That's true. जो the factor which affect the crops, they can be grouped into 3-4 kinds. तो फैक्टरों को कौन कौन से ग्रुप थे? Factors depending upon
टेम्परेचर इफेक्ट्स, जो टेम्परेचर के इफेक्ट्स,
उन सब को हमने कहा था ये क्लाइमेटिक फैक्टर्स हैं। टेम्परेचर, सनशाइन, दीज आर द क्लाइमेटिक फैक्टर्स। मुझे ये बताओ, नाश्ता करके बैठे हो?
सर फिलहाल तो नहीं किया हुआ।
ये भी चक्कर है। मैंने सबको मैसेज है कि अच्छे तैयार होकर नाश्ता करके बैठा करो। दिस इज अ फुल टाइम जॉब, और इसके लिए आपको
Yes,
एनर्जी
sir.
भी चाहिए, फ्रेश जहन भी चाहिए। सारे बच्चों को कह रहा हूँ, और उनके अम्मा अब्बा को भी कह रहा हूँ कि इन्हें नाश्ता दे दिया करें। ठीक है?
Yes, sir.
तो ओके, गुड लक। मेरा मकसद किसी को तंग करना नहीं है, लेकिन इन्वॉल्व करना जरूर है। थैंक यू।
Yes, sir.
So
Thank you,
after
sir.
5 minutes we will be together again. Okay, आप बंद कर दो।